Folliculogenesis is the production of a follicle within your ovaries. A follicle is a layer of cells that surround an oocyte. At least that's what a follicle is in the ovary. So the supporting cells that support and the development of the oocyte, those are going to be follicle cells. So somewhat similar to our Sertoli cells in the sperm. Within the ovary here, this is an ovary, this whole thing. And all this little stuff in here, and see even these little tiny ones, these are primordial follicles. These contain a primary oocyte. We're going to have development of these follicles, meaning they're going to get larger, add cells, grow, and that's going to occur. Eventually, the oocyte is going to become a secondary oocyte. The follicle will also change its name too. Eventually, you're going to have a mature follicle as well as with a secondary oocyte. So that's kind of our end game here, a mature follicle. What does that mean it's going to do? It's about to rupture and release its contents. Its contents is the secondary oocyte. That is called ovulation, when it's going to release its contents, right? So we're going to walk through the process of what happens to the follicle. And in that, I'll tell you what's happening to the oocyte as well. There's not as many changes that happen to the oocyte because the oocyte stays a secondary oocyte until fertilization. So there's not as many changes. The follicle is going to change more than the egg itself. So we're going to start with reviewing oogenesis. I'm actually going to pause the video and draw this in because I went through this in the other video. So I'm just going to add it here quickly. So here is our oogenesis on top here. All review. You've seen this before. So we're going to look and see what happens to the follicle during this time. Well, first, it's pretty easy. I'm going to draw the oocyte in there, but then I'm not going to tell you what's changes are with it because that's happening up here. So the oogonium is going to be surrounded by a primordial follicle. I need a new color here. I'm going to do light blue. This is going to be surrounded by a thin and single layer of cells called granulosa cells. These cells make up the follicle. That's basically all there is to it at this point. And I'm not going to draw nuclei on all of these, but remember that they're cells. Just want to remind you of that. So these are our granulosa cells. Granulosa cells. And our follicle is going to remain a primordial follicle until after puberty. So we've got our primordial follicle. So even when it's a primary oocyte, at first it's still going to be a primordial follicle. As we get close to puberty, somewhere around here, we are going to start building up those cells around the oocyte. So here I'm going to go after puberty, and we're going to draw multiple layers of granulosa cells. They become kind of cuboidal, actually, so the granulosa cells, I'm going to say, becoming cuboidal throughout kind of childhood towards puberty. I'm not going to draw every single step that happens, right? It's a process. But by this point, by just after puberty, we're going to have multiple layers of, I'm drawing them a bit bigger because they're cuboidal. These are still granulosa cells. And yes, their function will become important. They have nuclei in them. You also start to develop then another layer of cells around the granulosa cells. Again, this is a process, so this might happen a little bit, after the layers of granulosa cells start to develop these thin layers. And actually, I'm gonna draw them like this. These are theca cells. Okay, so that is become a larger thing, right? This is now going to be actually our secondary follicle. So pretty much our primary follicle. I'm not going to ask you to distinguish between primary and primordial. Our primary follicle is kind of a single layer of cuboidal granulosa cells, granulosa cells. Here, this is now our secondary follicle. Now that it has these two different cell types on them. These granulosa cells, as now they're big, they're cuboidal. What do cuboidal cells do? They produce stuff. They can secrete or absorb things. These ones are going to secrete fluid. That's what this is supposed to be. They're going to secrete fluid into this space here. And they're going to, it's going to result in the development of what's called an antrum. An antrum is going to be a space that surrounds our oocyte, still a secondary, still a primary oocyte. Still a primary oocyte. My timing is a bit off here. All right, we're good. Basically, what you got to do is know that at puberty, this first meiosis 1 doesn't happen immediately. It's not going to happen until the follicle is ready. So if you can be okay with this, I drew this up here because this can happen as soon as puberty begins. But this whole thing, I'm going to circle it in a different color. I'll tell you, we don't know where it happens, right? We're not there yet. This is going to happen after we get to the mature follicle. To become a mature follicle. So it's actually going to happen kind of right here. Okay, so let me keep drawing my, where are we? What am I drawing here? I'm drawing a tertiary follicle, which is almost mature. And it's going to have granulosa cells, one layer around this oocyte, and then multiple layers, just like before, around the antrum. So the only difference now, I'm drawing myself a little messier, is that that antrum has built up. That is, the importance of that is it's fluid that's going to cause pressure to build up. And this one should be a little bigger, right? The whole thing does get a little bigger as well. Pressure is going to build up in that follicle. So we've got a tertiary follicle. I'm not going to quiz you on the stages of follicles in terms of being picky about primary, secondary, tertiary. We care about a mature follicle, for sure. At this point, see my arrow coming in, meiosis 2 is going to happen. Just to emphasize that even more, it's the same thing as what happened up there. So now what's inside here? A haploid cell. The other polar body, right, which we've shown up here, is dismissed. And then we still have the granulosa cells surrounding And the antrum, I don't really have space even to make it big enough. The antrum's gotten really, really big. I wish I could draw this whole thing bigger. We'll draw a whole lot of granulosa cells just so at least you can see the follicle is going to get bigger, right? You saw that in that previous slide of the ovary. Follicles get big as they mature. The bigness comes from both granulosa cells dividing, multiplying, enlarging, producing more fluid, and the fact that they're producing more fluid, putting that fluid into the antrum, and the thecal cells are also dividing. Okay, here is our antrum full of fluid. That fluid, there's a lot of pressure in here. It's going to burst. So this follicle is going to literally rupture. I'm gonna have to move myself here and use this space up here. We're going to have rupture of the follicle. The follicle itself is going to become what's called a corpus luteum. It's going to be the remnants of the follicle. And of course so here's our oocyte, still a secondary oocyte because it hasn't been fertilized yet. It might be fertilized soon. So the primary oocyte is released into actually the peritoneal cavity where it's going to be picked up by the fallopian tube. It's a kind of a cool thing. The fallopian tube has these little fimbriae that make waves and allow the egg to pass into the fallopian tube. And the follicle is now actually I don't want that color. I want the blue to represent this with granulosa cells. It's kind of like, it's got some cells there still, but it is ruptured and broken up. It's no longer a follicle. What is it? It is the corpus luteum or luteum. Luteum. It's the body that's left over from the follicle. So these have become separated. The oocyte lives about 24 hours. Hopefully will travel down the fallopian tube, and depending on what your life situation is, either hopefully will be fertilized by a sperm and complete meiosis to become a zygote and then implant in the uterus, or it will not be fertilized, which happens more often than not. It will end up just dying, and it's very small. It'll be excreted out with the menses that happen each month. And so that's it for folliculogenesis. We actually are going to do this again, though. We're going to do this with the menstrual cycle, the ovarian cycle. We're going to put this all together. Hormones, folliculogenesis, oogenesis, and uterine lining changes that are important